Okay, so in chapter 2.1, we learned about how to find the derivative of a function using the general or the limit definition of a derivative. But now that we learned the power rule and other shortcut methods, we're able to find the derivative the derivative function a lot more efficiently. But sometimes you're going to see these problems where they're going to be testing you on your knowledge of these notations. So not asking you to solve, but to be able to recognize the pattern and to figure out what the problem is asking you to find. So let's review here. This is the notation for finding the derivative of a function or evaluating the derivative at a point. So f prime of x is equal to limit of f of x plus h minus f of x over h as h approaches 0. So this is essentially using the limit definition and the slope formula to find the derivative or the exact slope at a point for for a curve that is where its slope is ever changing. Okay. But let's just work through some problems here that with the methods that we're used to with the power rule and evaluating these answers, these solutions here, going through the method that we know how. So let's say we're given f of x equals cube root of x squared, right? If I ask you to find the derivative, you would simply first get it into exponential form, and then you would decide that this is sufficiently ready for us to apply the power rule. So we bring down the 2/3, and we subtract 1 from the original exponent, and then we bring that variable down to the denominator. So now this represents the formula, the slope finding formula for this function cube root of x squared, right? So any x value I plug in return, it'll tell me the slope, the steepness of the curve at this point, at a specific point. Okay. All right. So now part B, find f prime of 8. So now it's asking, what is the slope for this curve going to be at x equals 8? So if we plug 8 into the derivative function in return, it'll tell us the steepness or the slope. So we plug 8 simply into the derivative function. So f prime of 8 is equal to 2 over 3 times 8 to the 1/3, and that's going to get us to f prime of 8 is equal to 2 over 3 times, now cube root of 8 is 2, and the 2's will cancel out, leaving us with 1/3. Okay, so easy enough. Not much of a challenge there. That's something that we've seen already, and we're proficient at it. Okay, so now let's go back and see if we can approach the same problem, the same function, using the limit definition. Okay, so limit definition says that we're going to take the function and we're going to plug it into this form here. So this notation says take every x that you see in the original function, pull it out, and in place of it, put the x plus h. So here's my original function. I'm going to take the x out. In place of it, I'll put the x plus h. So that looks like this. Cube root of x plus h squared. Minus the original function. So the original function is cube root of x squared. So minus cube root of x squared all over h as h approaches 0. Okay. So I want us to take a look at this notation so far. If we were to try and algebraically solve, it's not going to be as clean because this is we can try to do a conjugate method, but this is cube root, so it's going to be a little messier to do, and we never really have to worry about having to evaluate something as algebraically messy as this. And that's why when we did 2.1, we only used the limit definition for easier functions that are algebraically manageable. But even if we can't solve this, we know that if we were to take this all the way down to simplified form, this should take us all the way down to 2 over 3 x to the 1/3, right? So the big idea is that this messy notation is the exact same thing as this right here, right? Because they both represent f prime of x, but just one is a lot cleaner than the other. But the idea is that these represent the same thing, okay? So if, let's say we didn't clean this up and we just left this as this one messy notation. So if this is f prime of x, then how can we find f prime of 8, right? Well, let's see what we did over here. If we want to find f prime of 8, we simply plugged 8 in for all the x's of my derivative, right? So f prime of x is 2 over 3 x to the 1/3. F prime of 8 is just 2 over 3 times 8 to the 1/3, right? So all we did to evaluate f prime of x at 8, we just replaced all the x's of my derivative with 8. So if we use that same idea, if this messy notation is f prime of x, then if I replace every x I see with 8, then this would then represent the slope of the curve at x equals 8. So if we do that, then that's going to look like this, right? We take our f prime of x, okay, just like over here, and we replaced every x with 8. So we do the same thing here, replace every x with 8. So now this is the same thing as this right here. Okay, it's just that with this we can't easily find the value, but we know that this will come out to be 1/3 because we can do the same thing in a more efficient way with this method. Okay, so the big idea is that can we look at this notation and recognize that this is asking us to find the derivative for a specific function at x equals 8. Okay, so we're going to see if we can start at this point and work backwards to see if we can identify where the original function came from. Okay, so that's what we're going to do with number 3. Okay, so number 3, find the limit as h approaches 0 of cube root of 8 plus h squared minus 4 all over h. Okay, so can we look at this function? Can we look at this notation and see where the original function came from? Okay, so the best way to tell is to focus on the portion that has the h in it. So because this represents f of x plus h, this represents f of x. F of x usually is not going to give us enough clues to help us backtrack. So if we just cover this up, easy way to do this is that something must have been plugged in to get this 8 plus h to show up, right? So, and it's because we replaced the x plus h in for x. So any parentheses that you see with x plus h or 8 plus h or anything with h in it, just think of this as x. Okay, so if we think of this as x, then the original function is just going to be what? Cube root of x squared. And so this notation is coming from this cube root of x squared. So we should have to know that this is asking us, this notation is asking us, this is representing f prime at a specific value. This is asking us to find f prime of 8, right? So if we can find out what the original function is, and we can figure that out by just replacing the parentheses with x, the original function is x to the 2/3, and the x value is 8. So just like over here, if you saw this term here, this is basically plugging 8 in for the x. So we're just plugging 8 in for the x. So it's asking us to find f prime of 8. So f prime of 8 at x to the 2/3 is simply finding the derivative for x to the 2/3, which is 2/3 x to the negative 1/3, or 2 over 3 x to the 1/3, and then plugging in the 8. So that's going to get us the same thing that we did here, 1/3. Okay, so number 4, if we take that same approach, we know that this is in the limit definition notation, and this is representing, this is saying find the derivative for a specific function at a point. Okay, but let's see if we can identify what that function is. So again, this is coming from some x that's been replaced with x plus h. So if we look at what's inside the parentheses and replaced all this with x, our function is simply x cubed. This is coming from x cubed that's plugged in halfway and not worked all the way through. So this function, this is coming from the function x cubed, but this notation is asking you to find f prime at a specific x value, and that x value is -2. So if we know that this is what we start with and this is where we want to go to, then we can simply find the derivative for this function using a much more efficient method, which is power rule. So once we find the derivative using power rule, so x cubed becomes 3x squared, we simply evaluate the derivative at -2 by plugging -2 in for x, and that'll get us 3 times 4, which is 12. So this will, if we work this all the way through, it'll get us down to 12. Okay. But many times the problems presented to you will be so algebraically difficult that you're going to have to use knowledge of limit definition to work your way to the function and use a much more efficient method such as power rule to get to your answer.